So this is a good opportunity to take a look at a concrete example of what we're talking about when we see libuv and asynchronous code, buffers and callbacks. Let's see that come together by looking at files. I'll start off by going out and using require to get the built-in fs module. That's fs.js inside the Node source code on the JavaScript side of the core. And that deals with the file system. That wraps up the C++ code that lets me get lower level and deal directly with files. Now I'm going to create a new text file. I'll just say greet.txt and I'll say hello world. Save that. Go back and we'll use a method on the fs object, because when I go and get it, I get back an object from require. And I can then go get some data from the text file. In other words, I can read the text file. Now, we're dealing with files on our operating system. So that means we're dealing with normally binary data. So I need to be able to deal with binary data in reading the file. So I'll call fs.readFileSync. That's the first thing we'll show. And it takes some parameters. The first thing it takes is the location of and name of the file. Now I've put it here at the same level as my app.js file. To be clear then, I'll use __dir_name. Do you remember that? That is one of those parameters passed to me when this code is wrapped in that function. And it gives me the path to the directory that the code I'm running lives in. So I can use this, since it's the same directory, and just say /greet.txt. So this will be the path to this location, and then I want the actual greet.txt file name, so this whole thing concatenated together will be the full path on my hard drive to greet.txt. I can also specify the encoding as the second parameter here. That's not required because it will by default be UTF-8, but just to show what it's doing, it's looking at the file, it will read the binary data, and then it will use the encoding to determine what those zeros and ones mean. What do they ultimately map to as characters? And this wraps in the concept of buffers, because if I go open up in the Node.js source code the read_sync method inside fs.js, I can see that it takes, for example, a buffer. When this is called, it's given a buffer. And so it loads the contents of the file into the buffer. It needs to, because the buffer can deal with binary data. So when my file is read, it loads the contents of the file into the buffer first, and then uses the encoding so that I can get the string back. So after that happens, I can now use my variable, which now has the string. This file was read off of my hard drive. It used the proper encoding to get me back the proper characters from the binary data, and then I can output it. So I'll output hello world. See that? It just went out and grabbed the data. That is the contents of the file. Now notice this has the word sync on the end. This is Node letting us know very clearly with the name of its methods that this is a synchronous approach to reading the file. That means that when this line of code is run by the JavaScript engine, it will wait until the buffer is filled and it has the string back before the V8 engine will move on to the next line of code. Now, this can be useful when, for example, you're setting up initially your application, the first lines of code. Maybe you have a configuration file of some kind, and you need to read that before any other code can run. That's a perfectly valid reason to wait until the file is finished reading in order to move on to the next line of code. But in most cases, you don't want this to be synchronous, because perhaps you have many people requesting information from your Node application. And if you have many simultaneous users, what's going to happen is they'll all end up blocked, because JavaScript is synchronous even though Node is asynchronous. When we say to read this synchronously, we're asking JavaScript to just run this in its normal synchronous manner, which means that others requesting the same code to be run simultaneously will end up waiting a long time, because you might have many users and we're waiting for the file to be read. If the file is very large, we end up with a very large buffer. It could take a long time, relatively in computer terms. And so your application could slow down the more people you have requesting this code to be run, because every time it's run, it stops and waits for a long process to finish, potentially, especially if the file is extremely large. The larger the file, the longer the process. And there's other similar circumstances. So by default, if I just say greet2, I can just say read file. Read file, I'll just copy and paste. Same thing, we want the location. But this takes a callback. And the callback function that I provide will take two parameters, an error and data. If we were to go look at this in the Node.js source code, also in fs.js, we see the read file method, which takes a callback. And ultimately what happens is it goes off and says, all right, C++ code, do your thing. And remember libuv? Remember the event loop? libuv will go and ask the OS to do the work, and then when the event is complete, when it has finished reading the file, please run this JavaScript code. So this is the event loop. And it might take a long time for this file to be read, and that's okay, because the JavaScript code will simply keep running, and then the event loop will keep checking, and when the file is finished reading and I have my string, it will say you can now run this callback. And as soon as the JavaScript engine is finished running whatever other code it's running, it will invoke this function. And when it invokes this function, if there was an error, it will pass it as the first parameter, and otherwise any other data. And if there's no error, it will be null. By the way, this is a popular pattern in Node called error first callbacks. Big word alert. Boy, is this a big word alert. Remember how I said big word alerts were for concepts that sound a lot more complex than they actually are? This is a great example. Error first callback. It's a callback that takes an error object as their first parameter. And that's it. That first parameter will be null if there's no error. Otherwise, it will contain an object defining the error. And this is just a standard pattern, so we know in Node what order to place our parameters in for our callbacks when we give Node a function, a callback to invoke. This is so funny because it sounds so complex, but that's all it is. In fact, it may show up as a question you get in a technical interview for a job. And it sounds really complicated, but it isn't. It just means, by default, by standard, if you give me a function for a callback, the first parameter I will pass to you is an error. And if there was no error, I'll just give you a null in that first parameter, and then we go on with the rest of the parameters. So the first parameter is an error. And that helps because maybe you have different orders of parameters, different numbers of parameters, different callbacks. But I can always rely on the fact that the first parameter is the error. And that helps me in structuring my functions. So I have an error first callback for an asynchronous method. Remember, asynchronous means more than one thing happening at the same time. The JavaScript will be running through V8 while simultaneously I'm asking Node to go and read the contents of this file. And thanks to the event loop, I will simply have this function invoked when that work is complete and V8 has nothing else that it's doing. So let's see what actually comes back. If I console.log this data, well, look at that. that was my synchronous call, hello world. And this time I got a buffer. So what comes back by default is a buffer. Remember, it's loading binary data, so that's what it gave me, a buffer full of the binary data, a buffer full of the contents of that text file. Now I could convert this using the buffer toString, or I could just say, as my second parameter, the encoding that I'm expecting this to be, this file. If I include that parameter, then it will convert the buffer to a string and give me back the string. There it is, hello world. But in this case, it was asynchronous. So this function ran after V8 was complete doing its work and after this file was read. Let's prove that. Console.log done. So I have a console.log, the contents of the file, after a synchronous execution. I have an asynchronous execution where V8 will continue running, and console.log the contents of the file after that's done. And I have one more line of code after this asynchronous call that logs the word done. What order do you expect to see this appear in? What do you think? Which of these console.logs will run first, second, and third? Let's try it. There we go. Were you right? The done happened second. Why? Because this line of code ran the require function and got the fs object. This was specifically synchronous, so it waited till it got the contents of the file before moving on to the next line, and then ran that console.log, so that was that first hello world. Then it ran this line of code. This says, please go out and asynchronously get this file contents. And here's the callback for when you're done. And then V8 moved on, and V8 was running its code while that file was being grabbed. So V8 ran that line of code. And since the callback won't be executed until V8 is done running whatever code it was running, this last line will be run, so we see done. And then, at that point, the event loop had said, oh, the file is done reading, so I can invoke the callback. And so this function was invoked third. It's error first, and so my second parameter was my data, and that's the third hello world. Make sense? That's the power of asynchronous code and callbacks. Because if I had many people requesting this app and asking it to do things and working with it, this call to reading that file, especially if it was large, wouldn't slow down the application for people. They would simply be able to keep working. The app wouldn't freeze or hang because this is being done asynchronously and V8 is still running the JavaScript. So they could continue asking for other things, getting other data, and at some point, this callback will be invoked. Make sense? When you think about writing Node code, sometimes the idea of asynchronous code and functions can be a little bit overwhelming. It can be hard to understand at first, but you should understand it, and you should always lean towards the asynchronous approach versus the synchronous approach whenever available, because it will make your applications, your software, more performant. It will make it seem faster. It will be a better experience for your users. So wherever you can, if there's an asynchronous method available, use that one wherever you can. Make sense? Now, we actually have one other problem here. The problem is that this is using a buffer to load the file contents. And a buffer is just data sitting in memory. It actually sits on what's called the heap in V8, meaning that it's just a spot where data sits, or data that the application is using. And so Node sticks the buffer contents onto what's called the heap in V8, meaning the memory space that the JavaScript engine is using. If that file is very large and many people are running this program, you'll end up with many buffers that are very large in size. And so all of a sudden you'll end up having problems in your application using a lot of memory. This is a real problem. You could end up causing yourself a lot of grief when you actually put out your application in the real world. So we need a way, now that we've seen we can do it asynchronously for performance, to also minimize how much data we're working with at any one time inside the buffer. Let's get that done.